All right, good morning, grade 11s. So this is just going to be a basic introduction lesson to quadratic relations. So yesterday you read through section 7.1 in the textbook and filled out the notes, and hopefully that went all right. So we're just going to kind of go over that today, just some basics of quadratics, and then how we are going to use our knowledge of quadratics to solve contextual problems. That's kind of what this whole unit is about. So if you refer to the notes that you just downloaded, okay, the bottom line here is that a quadratic function, all right, has a degree of 2. If you remember from your grade 9 math, that the degree of any function is the highest exponent um, above the variable. So here, x squared, okay, the degree is 2, so that makes it a quadratic. And this y equals ax squared plus bx plus c is the standard form of a quadratic function. And a cannot be 0 because if a was 0, then the equation would be y equals bx plus c, which you learned in grade 10 Intro to Applied and Pre-Cal, is that is a linear equation. And so we can't have that. If it's quadratic, a cannot be 0. So A, B, and C, as you read yesterday, are coefficients. And what they do is they kind of just change the shape of the graph of a quadratic function. All right, so we go to Desmos, we'll take a look at the basics of a quadratic equation. So I'm going to write out the standard form. So y equals ax squared. So to type that in, we just do the squared. So y equals ax squared plus bx plus c. I'm going to add sliders for all of these. Okay, so the slider is just going to help us change. So right now, if we have set b to be 0 and c to be 0, we'll investigate what a does. So a, okay, as we see here, if we make it bigger than 1, positive, it makes it more steep. It steepens the parabola. So just pause for a second. This is the characteristic shape of a quadratic graph. This is called a parabola. And you'll notice that a parabola is symmetrical. Okay. There's two parts. There's the left and the right part. So the line that cuts the parabola in half is called the axis of symmetry. Okay. So that makes it a mirror image on the left or the right. And the parabola has a start point and then it goes up forever, or the opposite, as we're going to see in a second. So when a is positive, we notice that the parabola opens up. So it's a large value, infinity, comes down to a minimum point and then goes back up again. And so that point, we call it a vertex. Okay, so that's the center of a parabola. When a is negative, you'll notice that it flips. So now the parabola opens downwards. Okay, so it would be going towards negative infinity, the range, and then it would come up to a maximum point. So the vertex is a maximum when a is negative, and it is a minimum when a is positive. So that's the impact of the a value. So the a, when it's positive, it opens up, and when it's bigger, it makes it steep. When it's between 0 and 1, notice how it gets shallower and shallower and shallower. And if you have it to be 0, then of course you don't have a parabola at all. So when a is negative, it goes down, and between 0 and -1, it's a shallow parabola, and then it gets steeper and steeper and steeper. Okay. The b value. Okay, so the b is next to the x, so when b is positive, it shifts the parabola to the left and down. You see the vertex moves down. Okay, when it's negative, it shifts to the right and down. But the bottom line is you need to know that the b value shifts the parabola left and right. So again, positive b value shifts it to the left, negative shifts it to the right of the y-axis. And the c value, notice the c, there's no variable, so we call that constant. All right, when it's positive, it moves the parabola up, and when it's negative, it moves the value down. So it moves it up or down. The B moves it left or right. And the A, when it's positive, moves up, makes it steeper. And when it's negative, it's down and steeper. So an interesting point to note, okay, is that the C value is always equal to the y-intercept. So here the y-intercept is 2.3, and the C value is 2.3. If I make the C value 4.5, not surprisingly, the y-intercept is 4.5. Likewise, if I make it a negative 4.2, the y-intercept is negative 4.2. So you should notice that the C value is equal to the y-intercept of a quadratic function. Okay, so we kind of explored what the parabola does. All right. So notice that the vertical line of symmetry cuts through the vertex. So again, if I go back to Desmos, we'll move it to the left. Sorry, move it to the right. I'll move that up. There. Okay. So you can click on the vertex. Right now, my vertex is the x value is 1.462, and the y value is 2.123. Okay, so that's the smallest value that that's the smallest value of the function. Okay, and this is the axis of symmetry. So if I, on this line here, I type x equals 1.462, you'll notice that that goes right through the axis of symmetry. It goes right through the vertex. So the x value is the axis of symmetry, and the y value is the maximum or the minimum. For example, if we move it down, sorry, if we flip it like that, all right, here we have the axis of symmetry is now on the left side, so negative 0.792. So x equals negative 0.792, and you can see that it cuts through the x-axis. I mean, it cuts through the axis of the vertex. Again, what I want to draw your attention to is that the x value is always going to be the axis of symmetry. The y value is either going to be the maximum or the minimum of the vertex of the quadratic function, depending on if the function is opening up or down. So in this case, it's opening down. So that's the largest, that's a maximum value of the quadratic function. If this up a bit. If we have this opening up, now this represents the smallest value, the minimum. So you need to note that as well. Okay. So the changing the b value shifts it left to right, it changes the line of symmetry, and the constant term c is the y-intercept. Okay. So some characteristics of the parabola. Okay, when we have it in this form, y equals ax squared plus bx plus c, if the parabola opens down, the vertex is the maximum value. If the parabola opens up, then we have the y-coordinate is the minimum value. So that's very important. This parabola is symmetrical about the axis of symmetry, which is a vertical line. It cuts it in half, which means that if you have a point on one side of the parabola, okay, you'll have the equal point on the right side, and the distances will be the same from the line of symmetry. So I can show you that here. So if we go to Desmos, I'll just make up a quadratic function. So y equals 1.2x squared minus 2.4x plus 1. So notice here that the y-intercept is 1 because the c value is 1. Okay. We have two x-intercepts. We can click on them. The x-intercepts, if I zoom in here a bit, there we go. The x-intercept would be, the first one would be 0.592, and the second x-intercept would be 1.408. All right. So our axis of symmetry is at 1 because our vertex is 1, negative 0.2. So I'm going to type out the equation x equals 1 so we get a visual. All right, so what we're saying about the axis of symmetry is that it cuts the parabola in half. So if we have a point on one side of the parabola, okay, there should be the same point on the opposite side, and they should be the same distance away. So for example, I'll use the value of 1. So if I just type in y equals 1, okay, now we have this point here, 0, 1. Okay, that is, of course, the y-intercept. And it is 1 unit away. It's 1 unit to the left of the y of the axis of symmetry, which means that the second point, when y equals 1, see y is 1 here, it goes down, and then y is 1 again, it should be the same distance away. So this first value of 1, y equals 1, is 1 unit to the left of the axis of symmetry. And on the right side, of course, it is 1 unit away, because here we have x is 1, x is 0, x is 2. All right, so we have 1 unit to the left, 1 unit to the right. And I hope that makes sense to you. All right, the axis of symmetry cuts the parabola in half. So let's pretend that we didn't know this point. If you knew that the axis of symmetry was at 1, and you knew that this point was 0, 1, this point obviously would have to be 2, 1, because the x distance to the left and to the right must be the same. So that's 1 to the left, 1 minus 1 is 0. Then this would have to be 1 plus 1, which is, of course, 2. So that's how the symmetry works for parabolas. We'll talk a bit about domain and range. Remember, domain is the set of x values, and the range is a set of y values that are described in the function. So notice, if there's no restrictions, a parabola for the domain, it's going to go all the way to the left, so negative infinity, and go all the way to the right, positive infinity. But notice that the range is restricted. If the parabola opens up, the range starts at a minimum value, okay, and goes up. So for example, okay, I'll just type it here so you can see, but the range, okay, would be the minimum value, which is negative 0.2, and it would go all the way to infinity. I'm just typing this out as an example. So that'll be the range. The domain would be negative infinity to positive infinity. Oh, it actually kind of gave you the symbol. That's kind of cool. Okay, so the range is restricted always, and the domain is not. But when we get into context, we're always going to be hanging out in quadrant 1. So then there will be a restriction on the domain as well. For example, if we're talking about the height of a ball thrown over time, you can't have negative time. So we're always going to be hanging out in quadrant 1 as we go into the contextual examples. But for right now, we're just doing the basics without context. So I hope that that kind of gives you an introduction to some parabolas and the quadratics. All right, note that that's the standard form, okay, and be comfortable with plugging these into Desmos, okay, and getting the information. So I'm going to go through a practice example here, just for getting the information from a graph. So let's say we had the equation y equals, we'll do it this way. Okay, so let's say we had y equals negative, do it this way, just bear with me. We'll say negative 1.08x squared plus 2.65x minus 7. Okay. All right. So we're going to analyze this, and we're going to get some information. We're going to figure out the axis of symmetry. Okay, we're going to determine, is this a minimum or maximum value? Okay, the vertex. Actually, we'll do the vertex first. The y-intercept, the x-intercepts, domain, and the range. Okay, so some analysis from this form. So now this is the standard form. So without even graphing, okay, we're going to use some of our knowledge of quadratics. Remember that if we have a negative a value, that the parabola opens down. And if the parabola opens down, then the vertex has to be a maximum. So without even graphing, we know that this is going to have a maximum value. And we'll figure that out. And we know that it's going to open down. The next thing we know automatically is the y-intercept, because we know that the c value is -7. The constant term c is the value of the parabola's y-intercept. So when we state the y-intercept, we can state it as a coordinate pair. So y-intercept would be x is 0 and y is -7. Or we can state it as y equals -7. Okay, so there's two ways we can state, sorry, that's in the wrong spot. There's two ways we can state the y-intercept. Typically, we will state it as a coordinate pair. Okay, so I haven't even graphed this yet, and we know that information. So we can get some information from the standard form, but what we're going to do is get this into Desmos. Okay, so we will go to Desmos, and I'm just going to reset Desmos, and we will begin to type in our equation. So y equals -1.08x squared plus 2.65x minus 7. Okay, so we don't see it here. All right, so we have to move. So now we could graph this if we wanted. We could snip it and put it into a Word document. So we could do that. So notice here, right away, we know it is opening down. Okay, the y-intercept is -7. So 0, -7, that is the y-intercept. The vertex is another important point. We can click on it. So this is it. Okay, click one more time. There we go. And what I'm going to do, I'm just going to, for learning here, I'm going to snip this. Oops, I missed it. I want to get the y, I want to get the x-axis. There we go. I'm going to snip that there, copy, and we'll dump it into our Quadratics Basics. Okay, so we'll put that there. All right. And resize. Okay. So we have our graph. Now notice that this graph does not touch the x-axis, so there are no x-intercepts, so there'd be none. So this we would say no, so there's none, and this means there are no real roots. Remember, roots is another name for an x-intercept. Okay, so there are no x-intercepts. The y-intercept is 0, -7. We clicked on it, but we also knew that because we knew this value of c was -7. We clicked on the vertex, so we can state the vertex coordinates. So 1.227, -5.374. So when we state the vertex, we always want to state it as a coordinate pair. So we always include in the brackets. So x first, 1.227, and comma, space, -5.374, -5.374. All right, so that's the coordinates of the vertex. The axis of symmetry. Remember, the axis of symmetry is the x value of the vertex. And so we always state, I'll put this in red, very important, the axis of symmetry is always stated as an x equals. So x equals whatever value, in this case, 1.227. That is how we state the axis of symmetry. Now, the maximum value. We know it's a maximum value because it opens up. It opens down. So it comes from negative infinity, goes up to a max, and it goes back down. That maximum value is always the y value. So it would be, the maximum value would be y equals negative 5.374. So that would be how you state your maximum value. Y equals whatever the number is. And again, it's the y coordinate. Okay, so we've gotten that information. The last is the domain and the range. So there's no restrictions here. There's no context. So the domain is just negative infinity to positive infinity. Okay, so remember with our interval notation, round bracket. So actually, we're going to go to insert. We'll do this in our equation editor. So round brackets, negative infinity to positive infinity. And you don't have to write the positive. You can just write infinity. So that's the domain. The range. So now the range goes from negative infinity down here, y, comes up to a maximum. It touches it. So that's the maximum value. So the range is going to be a round bracket. Negative infinity. And it's going to come up and touch the max, which is negative 5.374. And we close it off with a square bracket because it touches that. Okay, so this is just an overview of getting information from the quadratic functions, okay? And hopefully that helps your assignment, page 360, numbers 1 through 6. So hopefully you can check your work on that. And I'm going to be giving you some more questions today in the textbook without context, just the basics. We'll get into some context tomorrow. Okay, so hopefully this makes sense, grade 11s, and check for the assignment today in the textbook.